Unit 5, practice test number 3, quadratic equations. Questions 12 and 13 ask you to find the y-intercepts and x-intercepts. The x-intercepts are just the zeros. You find those by solving the equation, just like we did on page 1, problems 1 through 6. You solve the equation and find the x-intercepts that way, because the x-intercepts are what happens when y equals 0. The y-intercept is what, the y value when x equals 0. So I'll start with the y-intercept on number 12. Negative 3 squared is 9. 9 minus 16 is negative 7. So my y-intercept is negative 7. For my x-intercept, I need to make y 0. I can add 16 to both sides of this equation, and it will look like what happens when I complete the square. 16 equals x minus 3 squared. I take the square root of both sides. I can say that 4 equals x minus 3, or negative 4 equals x minus 3. In either case, I add 3 to both sides. Negative 1 equals x, or (7) equals x. So I can say x equals 7 or x equal negative 1. My x-intercepts are 7 and negative 1. Problem number 13 has the standard form. It's a little bit different, but the idea is the same. Once again, I've made another problem here that I'm going to work so that you can see how to do it, and you can then do question 13 and question 12 on your own. With this one, x squared minus 6x minus 6. First of all, my y-intercept is where x equals 0. This is 0, this is 0. My y-intercept is just going to be negative 6. A lot of you probably could tell that just by looking at the equation. My x-intercept, once again, is where 0 equals x squared minus 6x minus 6. To find the zeros that make this, to find the x's that make y 0, I have two options. Actually, I have 4 options, but only 2 of them are available here. I can't take the square root of both sides, and I can't factor this, but I can complete the square, or I can do the quadratic formula. Quadratic formula is fairly straightforward. I'm going to do the completing the square on this just so you can kind of see, once again, how that works. If you want